In this video, we're going to learn how to model applying the distributive property with either a tape diagram or the hanger model, or the hanger method. So the distributive property, which is something that should feel right to you, although you may not have seen it written this way before, that if you take 3 times and then a quantity, or any number, times a quantity that's in parentheses, like 3 times 5 plus 2, so basically you're taking 3 groups of 5 plus 2, that's the same thing as having 3 5s added together and then 3 2s added together. It's just kind of a different order of doing things. And that either way, whether you do 3 times 7, because 5 plus 2 is 7, and get 21, or 3 times 5 is 15 plus 6, you still get 21. That's the big idea here. We're just going to be applying it with algebra. Let's get started. All right, so first, let's say that you have been asked to write an equivalent expression to 4 times x plus 2. And remember, this is the same thing. The 4 next to the x plus 2, that's the same as if I said 4 times x plus 2. And then let's rethink about what equivalent and expression means. So equivalent means equal. So we're trying to find something that's equal. And then an expression is a piece of algebra that doesn't have an equal sign or a greater than or less than in it. So basically I'm trying to find a way to rewrite 4 times x plus 2. So equivalent expression basically means rewrite it. Rewrite it. Okay, and we are going to rewrite it using a tape diagram. All right, so we're using a tape diagram. So I've drawn out a rectangular model here, and because it's 4 times x plus 2, I'm going to break it into 4 pieces. And then each piece I'm going to label as x plus 2. So some unknown quantity plus 2, and that's happening 4 times. Okay. Now, if I've just been asked to rewrite this, so I have not been told that this equals anything, right? That doesn't equal anything. Not going to do that part. What I can see here is that I have 1, 2, 3, 4 x's. And I can also see that I have 4 2's. 1, 2, 3, 4. And so if I were to want to so this is an equivalent expression. That works. I could also say, though, that this is like 4 x's, and then 2 plus 2 plus 2 plus 2, that's like 8. So my equivalent expression to 4 times x plus 2 could be 4x plus 8. Let's do another example. This time I want you to try it first. So I want you to write an equivalent expression to 3 times the quantity 2x plus 1. Draw a model, see if you can figure it out. Pause and continue watching after you have your best guess. Did you model this by breaking it into 3 parts and labeling each one as 2x plus 1? That would be the right way to start. And then you can think about this. Well, I've got 2x and another 2x. I've got 3 of them. You might even have been able to skip the part where you wrote out those 3 2x's, because you can just kind of count them up as you go. 2x, another 2x, another 2x is a total of 6 x's. And then 1 plus 1 plus 1, that's a total of 3. So this is equivalent to 6x plus 3. Now you might be wondering, why would we need to do this? What's the point? Let's go ahead and see how this can help us solve an equation. Okay, so let's say we have the equation 2 times the quantity 4x plus 5 equals 66. And by the way, the 2, I've written it in front. It doesn't have to be in front. This is exactly the same thing as if I said 4x plus 5 and then times 2 equals 66. Those are the same thing. It's kind of conventional to put the 2 in the front, but it doesn't make any difference whatsoever. All right, so let's say we have this. So this means there's some number that if I do 4 times that number and I add 5, and then I take that whole quantity and I double it, I get 66. That is complicated. I don't even want to try and have to do those mental gymnastics. So instead, let's go ahead and use the distributive property, and then we'll solve. Now, I like using a tape model, but I'm going to do one with a hanger too, because I know some of you really prefer a hanger diagram. Okay, so on one side I have 66. 66, that side's easy. On the other side I have a lot of stuff going on. I have 4x plus 5, there's an x, and then an x, another one, and another one, and then I have a 5, and then, but I have to double that, so I have to do it again. So now I'm going to do another x, I'm going to do 4 more x's. These can get really big really fast. This is kind of why I prefer a tape model. There's 4x and then a 5 down below. Woo, almost ran out of room there. Okay, and so I want to figure out what all those x's are. So when I look at this, I can see that this is the same as having change my colors here, same as having 1, 2, 3, 4, 5, 6, 7, 8 x's, and then 5 and 5 is 10. So 8x plus 10 equals 66. Okay, now I want to get it so that those 5s are gone, because those are confusing me. So I'm going to take away 5 and 5, and I'm going to take away a 10 to balance it out over here. That'll leave me with 56. We'll do the same thing over here. So 8x equals 56. And then, so now I know I have 8 x's equaling a total of 56. And so if I just like break it up into those 8 parts, I should get that x equals 7. So each of those x's is worth 7. All right, I want you to try 3 more. You can either draw a model for each one, or if you think you figured out a pattern, you can try it without a model first and then watch to see my answers. Try them now. You're not needing to solve for anything. You're just applying the distributive property to rewrite it to an equivalent expression. Did you decide that the first one equals 3x plus 21? Because 3 groups of x's would be 3x, and 3 groups of 7 would be 21. Next one, hopefully you got 20x plus 50, because 10 groups of 2x would be 20 x's, and 10 groups of 5 would be 50. And for the last one, notice all we're doing here is I'm kind of taking this 9, and I'm going to multiply it, and then I'm going to multiply it. So 10 times 9 is 90x, and 9 times 1 is 9. All right, your practice problem. Your practice problem is to rewrite 2 times the quantity 6x plus 5 as an equivalent expression.